All right, so let's say something that we actually know about this approach to action selection, which is called epsilon greedy exploration. And what we know is that if the action selection is glee, which means greedy in the limit with infinite exploration, and that basically means that we're decaying our epsilon for epsilon greedy, that we start off more random and over time we get less and less random, more and more greedy, then we have two things that are true. One is that q hat goes to q, which comes from kind of the standard q-learning convergence result. But we also have something cooler in this case, which is that the policy that we're following, pi hat, is getting more and more like the optimal policy over time. So not only do we learn stuff, but we use it too. And this is an example of the exploration-exploitation dilemma. And exploration-exploitation is really, really important, not just because they're two words that surprisingly start with the same 5 letters, like unlikely letters, but also that it is talking specifically about this issue. Exploitation is about using what you know, and exploration is about getting the data that you need so that you can learn. And this is one particular way of doing it. Turns out there's lots of other ways of making this trade-off. And the reason that it's a trade-off is because there's only one of you. There's only one agent acting in the world, and it has these two actually somewhat conflicting objectives. One is to take actions that it doesn't know so much about so it can learn about them, and the other one is to take actions that it knows are good so that it can get high reward.
That makes sense. I never realized that exploration and exploitation shared the first 5 letters. I always knew that they shared the last 5 letters.
Oh, that's interesting too.
So if you take an R and turn it into an it, you move from exploration to exploitation. I feel like an entire political movement could be founded on that. But I'm not sure exactly what it would be yet. Maybe I'll work on that before our next lesson.
So I have an algorithm. There's a standard lemma in reinforcement learning theory called the exploration-exploitation dilemma. Sorry, no, lemma, the other kind of lemma. The exploration-exploitation lemma, which has to do with taking actions that are either exploring or exploiting. But I have one where you actually do teaching. You can actually, each time you take an action, it's either going to teach the agent something, it's going to explore or exploit. So I call that exploration, exploitation, or explore, exploit, explain.
Oh, nice. But you could have called it the exploration-exploitation dilemma because you used a lemma, and di means two sometimes, and you do the two things.
Well, in fact, dilemma does literally mean two. It's a choice between two things.
Right. So it's a dilemma.
Nice.
It's a lemma about two things.
All right. So it turns out there's a lot of other approaches to exploration exploitation, and some of them in the model-based setting, you can do a lot more with it, a lot more powerful things with it, because you actually can keep track of what you've learned effectively in the environment and what you haven't. So the algorithm can actually know what it knows and can use that information to explore things that it doesn't know and exploit things that it does know. Q-learning doesn't really have that distinction. It's a much harder thing to do. So that's what I wanted to tell you in terms of thinking about exploration exploitation. Does that make sense to you?
It does make sense to me. I think what the main point I got out of this, or a main point I got out of this, other than our incredible ability to get caught up in letters and coincidences of spelling, is that the exploration-exploitation dilemma really is a dilemma. It's like the fundamental trade-off in reinforcement learning. You have to exploit because you have to use what you've got, but you have to learn, or otherwise you might not be able to exploit profitably. So you have to always trade off between these things, and if you don't, you're bound to either learn nothing or to get caught in local minima.
I couldn't agree with you more. In some sense, if you think of reinforcement learning as being the question of model learning plus planning, there's nothing new here, because model learning is well studied in the machine learning community, and planning is well studied in the planning and scheduling community. And so, what are we adding to this? And what we're adding is the fact that these two processes interact with each other and depend on each other. And that's exactly the exploration-exploitation dilemma. And that's information has to go back and forth between these two processes that other people understand, and we're the glue.
Or the glee.
The glee glue.
I like it. That's beautiful.